let's jump into a few density examples. All right, so here's the first one. So as a research student, you have been faced with identifying densities. So we have our density symbol rho in the laboratory. You have been able to find the mass of one substance, which is 23.1 kilogram. Okay, so let's maybe write that down. 23.1 kilograms. You have also been able to identify the volume, okay, the substance occupies. So volume equals 1.283 times 10 to the negative 2 meters cubed. And for part A, what is the substance density in kilograms per meters cubed? All right, well, so this one is rather simple. Density is just mass divided by volume. So we're going to take the 2 right there. So that's 23.1 divided by 1.283. And this is to the negative 2. So let's put that in. Equals. And that would be 1800, point, I guess, etc. Okay, so 467. Okay, I'm going to round this to 3 significant figures, and I'll put it back into scientific notation. So that's going to be that. And this is kilograms per meter cubed. And that would be it. For part B, look up on the internet, okay, which substance this is. Well, okay, so this is, all right, so I hope you found it, okay, so I'm going to kind of leave you hanging in, but it is aluminum, all right, so, okay, I'll just write that in, okay, right there for you. So that's our first example. Here's another example. So a patient's blood sample is being diagnosed for abnormalities. The blood sample has a mass of 9.05 grams and occupies a volume of 8.92 milliliters. What is the sample's density in grams per milliliter? All right, so it says another rather simple one. So we have mass, 9.05 grams. We have volume, which is 8.92 milliliters. And since they want the density, okay, in here, so they want it in grams per milliliter, so we'll just take 905 divided by, we don't need to change any units in here, so this is already going to be in exactly what we need. So let's just take out the calculator in here, which is 905 divided by 8.92, and that would have been nothing else but 1.01, and this is going to be gram per milliliter rounded to 3 significant figures. And that is it for this example. And in this one, so if you know that the density is 1 times 10 to the 3, then what is the equivalent density, but in grams per centimeters cubed? What can you deduce from this? So this is a nice example because it kind of forces you back. Very often what you will find is you're going to have densities, so kilograms per meter cubed. This is the SI standard, right? However, okay, so it's very common to utilize grams per centimeters cubed, or sometimes this is written as grams per milliliter, okay, if you're talking about liquids. So these two are very common units for density, okay, with the first one, which is the SI unit. So if you take a look here, so what they give us, really, I'm going to just actually write this out. Okay, 10 to the 3 is just 1,000, right? So this is kilograms per meter cubed. So if you want to convert this back into grams per centimeters cubed, all right, so the first thing is, if you want to change it back to grams, so we're going to have to add a few zeros, so that would have been grams per meter cubed. And now if you want to get rid of the actual meter cubed, so 1 meter, this is now going back into centimeters, so you may or may not remember. So there's 100 centimeters, so this is for your prefixes, and you can cube this up. And as you're going to go and do this, okay, so notice 100, okay, cubed is going to be actually 1 million. So what you find is you get 1 million up on top, multiplied by, this is going to be 1 all over, and then another 1 million. All right, 1, 2, 3, 4, 5, 6. So therefore this and this cancel. So really what you get back is 1. which is exactly kind of what we started in here. So notice that, okay, we started in with 1 times 10 to the 3, and we get 1 gram per centimeters cubed. Now, be careful if you want to write this out. So you can write it in, with 3 sig figs, which would have been just this. So what do we deduce? Well, what we deduce is if you want to go between kilograms meter cubed, which is very often given, okay, and you want to go to grams per centimeters cubed, all you do really is divide by 1,000. So if you divide by 1,000, okay, you're going to get exactly what you have. And this is what happens. If you want to go back, if you want to go from grams back into kilograms per meter cubed, then instead of division, you're going to multiply by 1,000. And you're going to have exactly the same thing. Or, this is times 10 to the 3 division, or times 10 to the 3 multiplication. Yeah, so that is it for this example. And it's a very nice example to force you and think about the actual units of density. That's it. Here's the last one for this video. So air has a density of 1.29 kilograms per meter cubed. Okay, so that's the density that we have of air. I'm going to write it out, 1.29. So it's a gas, so it's not very dense. If the air fills a cylinder, okay, so look up the volume of a cylinder. So volume of a cylinder. So here it is. I just kind of drew it in fast forward fashion. So that is your cylinder. So what you have is, you have your base that you are going to be working with. So this particular base, okay, so that is pi r squared, right? So that's the area of the base. And then you have the actual height, okay, of the cylinder, which gives you the volume. So height right there. So the volume is equal to pi r squared, okay, multiplied by the actual height. So that's the volume of a cylinder. Now, this height, it tells us, so notice that the h is 25 centimeters, which is nothing else but 0.25 meters, if you wanted to talk about metric standards. And then it says the radius, okay, so within here is 8.5 centimeters, which is 0.085, and this would be meters, again in metric standard. And what do they want? So for part A, what mass would the air contain? Okay, so provide your answer in milligrams. Okay, well, it's not a very big cylinder, so I guess milligrams might work. So we'll keep everything in standard units, and then I'll change back to milligrams as needed. So what do we have? We know that the density is equal to mass times the volume, right? So that's what we have. Now, our volume, so if I substitute everything back in here, so my radius is 0.085. This is going to be squared, multiplies by my height, which is 0.25. So it's going to be rather tiny, right? So that's my volume in here. So I have this right here. I also have my density, which is 1.29. So that means my mass, if I was isolating this, is just density multiplied by V. And this is something you should get used to. And now that we have this equation, I can certainly substitute all of this in. So meaning my density and then my volume. So let's do that all in one shot there. So we have our density, which is 1.29, okay, and then the volume. So we have, so I'm going to just put in here, so we have pi times, so 0.085, this is squared, times 0.25. This is going to be rather small, and that's fine. So that's my answer, that's my volume, and now I have to multiply this by density, which was 1.29 for the air. So this is, really tiny, and this is 0.00, 732, okay, 0, 1, etc. But this is kilograms, right? So if you want to break down from kilograms to milligrams, all right? So going from kilo to grams, that's 3 decimal places, which would mean 7.3201, etc. Okay, so that would have been in grams. Now to milligrams, you got to shift over another 3, so 7320, right? So this is what we would have, and this would have been milligrams to 3 significant figures. So, the actual air itself was around 7 grams, which is puny, but, this is not a very big container. So that's what you would have for the first component of this question. For the second component, what weight does the air hold? Provide your answer in newtons. So this is another very good question that is being asked because you will be working with weights, especially as if you continue on learning from density back to pressure, kind of static fluids and so on. So in terms of the weight, well, the weight now, does it tell us? Provide your answer in newtons. Okay, well, if they want it in newtons, then it's going to be tiny. So don't forget that the weight itself is just mass times gravity. So our mass in kilograms, because we need standard units. Okay, so that was this, and hopefully I kept it on the calculator, times gravity's acceleration, which is 9.8. Okay, I did keep it, great. So I have my answer times 9.8. So this becomes 0.0717 newtons, right, to 3 significant figures. That's what you would have. If you want to put it in scientific notation, you can. But that's all that you would actually do for this. Okay, so that is it for this example. All right, so thanks for watching. See you in future videos. Bye, everybody.